What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. So, in this video, we will be looking at part 4 of our MatPlotLib tutorial series. So, if you have been following along, right, you'll know that in the previous video, essentially what we did is we looked at various ways to go about plotting a curve. And by curve, I mean a line graph. So, I will run this script here, this cell here, just to show you that we were dealing with line graphs. Now, what we will do in this video is we will explore, a few more of the different types of visualizations we have, scatter plots, bar plots, and so on. So it will be fun. Now, what I'd like to mention to you, right, is that you see, I'm pretty sure you'll agree with me, okay? When you see when we display a curve, okay, when we display a line graph, we implicitly assume that one point follows another, okay? And after that, after plotting all those points, essentially what we do is we join the dots, okay? So in the same order in which we plot the points, we will thereafter proceed to join the dots, and the end result after the joining operation has been done is what gives us a line graph or a line plot. Now, in some situations, okay, the data that we work with, it is possible for one point of the data to be independent from the other points, okay? And the most simplest way in which we can represent such data where one point is independent from another point is to show the points without linking them, without joining them, okay? And instead of having a line graph or a line plot, essentially what we have is a scatter plot, okay? Because think about it, guys, the only way in which a line plot arises is from a scatter plot. Essentially, a line plot is a scatter plot that has the dots joined in the order in which they have been plotted. So now what I'd like to demonstrate first for you guys is MatPlotLib allows us to, actually plot a scatter plot. So let's actually proceed to plot a simple visualization. So we'll do import numpy as np. Numpy we are using for generating our dummy data. So I will import matplotlib dot pyplot as plt. Next, what I'd like to do is actually generate some random data, numpy.random.rand. So what I'd like to mention to you guys as well is that you can set a random seed if you like, okay? I won't be setting a random seed here. You may do so if you like. So because of the fact that I'm not setting a random seed, each time we run the script, the scatter plot will look different. So let me actually remove this line plot. So data is equals to numpy random.rand. The shape is 1024 by 2. So we'll plot x and y. Since we have two columns of data, we can simply plot column 1 against column 2. So matplotlib, the method we will utilize is plt.scatter. As you can see, the two important arguments that I need to pass are x and y. So let me pass in data, and I will slice all rows column 0, that's going to be the x values, data all rows column 1, that's going to be the y value. So plt dot show. I hit Control Enter, and this is what I have. It is kind of clustered because of the fact that we are generating 1024 points within the normal distribution values. Okay, so what I can do to make this even much more, I would say, simpler, suppose we are plotting just 200 points, and yeah, you have it. It is kind of spaced out because of the fact that we have less points. So you guys can play around, right? There are endless ways for us to generate dummy data using NumPy and other packages, so you guys can play around with that. Essentially what we have here is a scatter plot. utilize the plt.scatter method to create your scatter plot. So that's that. Now what I'd like to move on to actually discuss is, I think, one of the most simplest and common types of graphs that we actually utilize. It is called the bar plot. So bar plot, or you guys may call it the bar graph. So let's comment this here as well. The scatter plot. So that's good. Essentially what we can do here is import matplotlib dot pyplot as plt. Let me clear these visualizations. So what you will find as we learn more of these visualizations together, you will gain insight into the ways or the requirements, yes, the requirements that are needed to create that specific plot. Okay, you guys saw for the scatter plot, for the line plot, and so on, we required x and y values. Now think about it, right? In the real world, in the bar plot instance, when we are plotting a bar plot, essentially we have these labels for the x-axis, and the y value or the y-axis has these numerical values, and the length of the bar itself that is stemming from the x-axis tells us the y value. Okay, so if that makes a little sense to you, don't stress about it, because we will view an example right now. So I will set up this array containing my data. Suppose I'd like to have the values 5, 25, 50, and 20. Those are that's four values that I have. Now essentially what I will do is plt.bar, that is the method which we use, plt.bar. Now for the x value, what I want you to focus on here is these two arguments or parameters, x and height. X is those labels. X can be anything. Okay, if we were measuring, for example, liters, milliliters, and so on, that's what x would be. X can be a string value in simple terms. Okay, it can be a sort of label, a tag. Okay, for the simplicity of this exercise, I'd like to just set the x value. Since we have 4 bars that we will be plotting, I can set my x values to be equals to the range, the length of data. So since I have 4 elements inside data, essentially the range will be set to be equals to 0 to 3. So that's going to be the labels for the x-axis. And I am mentioning this again. The x-axis can take on string values, okay? It's tags. And I will demonstrate this to you shortly. So that's the x portion which we just sorted out. We know it will take in 0 to 3. So the data itself for the height, all I need to do is pass the array itself. Automatically the bar function will map the respective x value to the respective data value or y value. Okay, so essentially the first value in the range function will be assigned the first value of data, which is 5. The second value will be assigned the second value in the data, which is 25, and so on. So plt.show and control enter, and this is what we have. It is easy. So another option for you, if you don't feel like just assigning numbers to the x-axis, because I mean that is kind of boring, right? In the real world especially, you'll have the ability to pass an array containing the labels that you'd like. But again, I'm reinforcing, guys, the number of data points that you are plotting for the x-axis needs to be equals to the number of data points for the y-axis. So data itself is telling me that I will have 4 bars for this plot. So I need to pass 4 labels for the x-axis. Essentially, there should be a label underneath each of these bars itself. So what I will do is, let's just be a bit boring. So I will call this x1 just to show you that you can set string values for your x-axis. So x1, 2, 3, and 4. That's that. I do a control enter and I have it. As you guys already see, it has changed. It has changed to string values that have taken the place. This is what we had using the range function, and from manually, changing the labels of the x-axis, we have this. So it is super powerful and intuitive, because when we are working with actual data sets in the near future, we'll have the ability to plot exactly what we'd like to plot. Okay, if the first bar is representing maybe number of students, if the second bar is representing, number of cars, and so on, so the possibilities are endless. Now, this is us doing a bar plot. So oftentimes what you'd like to do is maybe just tamper with the thickness of the bar. So I will demonstrate that now. I would like to demonstrate that to you guys now. So let's do, what I would like to do is, guys, I would like you to copy the importations. I would like you to copy literally everything we did before, paste it, because all we are working with now is one more parameter. That parameter is called width. As you can see, x, height, width. Initially we worked with x and height. Those are the compulsory parameters. Width is not a compulsory. It is defaulted to the size of 0.8. So the higher you go with the number, the thicker the bar. So that's what we will do. So let's actually proceed to do width is equals to, I would like to set this to 0. Let's do 0.5. And as you can see, the bar's thickness have decreased. Now if I do a size of 1, as you can see, the bars kind of, I would say they just fit the plot itself. Okay, so that's that. Now this is interesting stuff here. You guys can play around with the width parameter. So I will type out the names of the parameters for you. We have x, we have height, and we have width. And as you guys can see, go ahead and play around with this value itself, change it to 0.2, the bars become super thin, and so on. So another cool thing that I'd like to show you guys, right? In the real world, see, this is this is a vertical bar graph. We call it a vertical bar graph because of the fact that the bars itself are vertical. Now, in actual sense, and it is a plot that also exists, you do get horizontal bar graphs. So horizontal is where it runs from left to right. So essentially we take this plot and we just turn it. Okay, that gives us a horizontal bar graph. Now MatPlotLib allows us to have that kind of feature and functionality as well. I will demonstrate it to you. So I'll create a new cell. I copied, I pasted. What you would need to do, okay, is just remove this plt.bar, and this method for plotting the horizontal bar graph is actually bar h. As you guys can see, I am required to pass in y and width. Okay, y and width. The height of the bars, or the thickness rather, is defaulted to 0.8. So y and width. Now let me provide you guys with a simple example. Okay, the horizontal bar graph is nothing different to the vertical. It's just I would say the representation. Okay, essentially in a vertical bar graph you'd have the bars vertically, and in a horizontal one they would be going left to right. Okay, so for y we are passing the y is representing the labels. Those x tags. In a horizontal bar graph, it's simply swapped. X becomes y, y becomes x. So y is going to contain the labels for us. So I can set this to anything I like. Remember, we can do strings, numbers, and so on. I will keep it simple just for demonstration. I will set the y labels to be equals to x1, 2, 3, 4. I think let me actually tamper with these data points because it would be boring to keep viewing the same things over and over again. So let's do maybe a 50, a 25, a 5, and a 13. So that's fine. So what I'd like to do now for the width of the bars, all I have to do is pass in the data points themselves. And I told you guys the number of x and y need to be equal. The number of points you have for the x values or the number of labels needs to be equal to the number of points you have for the y. Okay, the same rule applies for the vertical and the horizontal bar graph. Now essentially when I run this, you will see a horizontal bar graph. So control enter, and as you guys can see, MatPlotLib is super interesting, right? As you guys already probably realize that there are several possibilities we have for visualizing our data in Python. Now this has been interesting. Before I actually conclude the lecture though, I would like to plot multiple bar graphs for you. You may ask, right? We've seen how to plot multiple, line graphs on one canvas. Scatter plots, plotting multiple on the same canvas is nothing difficult as well. You just replicate the code. MatPlotLib automatically assigns different values, or colors rather, to the different plots. Now, what I'd like to show you is how to plot multiple bar charts or bar graphs on the same canvas. Okay, this is how we do it. So I will comment here. I'm actually typing the word comment. So let's do plotting multiple bar plots on the same canvas slash set of axes. So that's fine. Import numpy as np, import matplotlib.pyplot as plt. Let's set up our data. Since we are going to be plotting multiple and I should mention we are plotting a vertical bar graph, okay, the standard one. So we'll utilize plt dot bar. The order of that is x and the height. So since we are going to plot multiple, for the height, what I can do is I'll just set up one array that's containing multiple sub arrays, and then we can slice the data for the heights instead of having three separate arrays. So what we can do is I will populate now. I will say I have 5, 25, 50, and 20. That can be the first plot. For the second plot, suppose I have the values 4, 23, 51, and 17. For the third plot, suppose I have the values 6, 22, 52, and 19. So that's that. Now that is the height, the data points. Think of it as the y values. I need the x values. For x, all I can do, again, just to keep it simple for you guys, numpy.a range, I can do 4. So that's fine. Now moving on, let's actually get to the plotting portion of the plot or the graph itself. So what we will do is, remember, we are plotting 3. There's several ways you can do it. You can loop through all of these, in a for loop, which will give you the description of all 3, and you can call the plt.show after the loop ends, or you can really just do 3 individual plt.bar like this, and at the end you can do plt.show. This is what we will be following. So let's go ahead, let's get to it. For the plt.bar, I need x, I need height. So let's do x is equals to, and I have my variable x, and I will add 0.00 So essentially, the first bar plot is going to be plotted using the standard values in the A range. So just to give you a bit of insight, right, in case you forgot, we did cover the A range function in our NumPy tutorial series. It will generate us values from 0 up to the number, excluding that number, okay? Similar to the range function. So the first bar plot will utilize these raw x values 0, 1, 2, and 3. So that's the x. For the height of the bars, for the y values, I will utilize the first bar plot values, which is data 1 or 0. Python is 0 indexed. So that's that. Now, essentially for the second bar plot, I can set so let me actually type the name of the parameter here. For the second bar plot, x is equals to x plus 0.25. The height of the bars will be set to be equals to data of 1, and the third bar plot would be equals to x is equals to x plus 0. Let's do 5. So we will keep a kind of consistency. Height is equals to data of 2. Now, let me run this, right? I want you guys to see exactly what happens. So, it says here, bar missing one required positional argument, x. Okay, so let me actually remove the names of the parameters to avoid confusion. Now, upon running this, as you guys can see, it works. But pay careful attention, guys. Notice that the bars are overlapping. Okay, I want you guys to get familiar with how MatPlotLib works. Okay, you are able to plot multiple bars on the same canvas. But think about it. If you remember, you and I know that the width is defaulted to 0.8. And think about it, this canvas has a fixed size. The canvas itself is not expanding nor contracting, okay? It is up to the bars to adjust themselves to fit properly on this canvas to accommodate each other. Now, because of the fact that we have each bar for each plot showing with a width of 0.8, there are overlaps that are occurring, okay? Now, this is when some basic math occurs or comes into the picture, okay? Essentially, what we can do is, you guys know, I mentioned this before, that when you plot multiple, functions or distributions on the same canvas, MatPlotLib by default, it gives a different color to each distribution. Now we have the ability to actually change the color of that plot manually, okay, and we do this by using the color parameter. The name of the parameter is color, and we have the ability to set this to be equals to a color. Okay, now for now I'm not going to get into detail with the kind of styling of the graphs. I'm just mentioning this to you now just to get you some experience, and so that we have a better understanding of how styling works when we encounter that in the near future. So all I'd like you to do for now is just set the first bar plot to be equals to, so basically color is equals to B. Now that B is standing for blue. And you guys saw the bars are overlapping. So what we can do is we will set width is equals to 0.5. Exact same parameter names, do color is equals to, and now we will say G, and we'll do width is equals to 0.25. Same situation here, color is equals to, let's do R. So BG and R, if you are unsure what that stands for, it basically means blue, green, and red. So same situation here, width is equals to 0.25. Now using those two parameter names, specifically just focusing on the width, okay, color is not important because MatPlotLib assigns color for us. Now focusing on the width parameter, you guys see we have altered the width of each of the bar plots. Now, you will see when we run this how the bar plot gets transformed. So I will do Control Enter, and as you guys can see, this is the new bar plot that we have. Okay, so essentially we have changed our bar plot using some styling techniques from this. This was kind of untidy, as you can see. If one has to, kind of make inferences of the data from this bar plot, it will be difficult. But using this bar plot here, things are much more easier for us. So that's what we have at this point in the tutorial. Now, essentially what we looked at in this video, we looked at scatter plots, bar plots. Specifically, we looked at the horizontal and the vertical bar plot, as well as plotting multiple bar plots on a single set of axes, okay, or on a single canvas. So that's what we have here. Now, I will end the video here, guys. This video is clocking about approximately 26 minutes. So with that, we will end the video here. Thanks for watching. Thanks for staying till the end of the video. I do hope you are finding all of these tutorials, kind of interesting, and you are just learning a lot. So thanks, guys. Thanks for watching. Thanks for staying. Good luck with your work, and I will see you in the next YouTube video.